Hello and welcome to another tutorial. So what we're going to be doing this time is we are going to be updating the character motor to support variable gravity. So this is something where the spaceship controller added in support there for variable gravity and being able to track that, and focused on the spaceship side and setting up the gravity tracking systems. Whereas in this case, I want to look at how do we update it for the character motor, because it also requires some very specific updates. So I've already brought in the gravity tracker, and the first thing that I need to do is I need to actually set up the key components for that. So what I'm going to do is in our scene, I need to create an object for our gravity manager. So the way the gravity system works is that the gravity manager is responsible for really just keeping track of all of the gravity sources that are around. And I will, in this case, attach the gravity source, and we'll go for the global one and attach this onto it. So we want that set up so Gravity Manager keeps track of all of the sources. Then the player itself gets a gravity tracker added to it. So I'm going to add a gravity tracker, and when we do that, we need to link it up to a rigid body as well, which it needs to be whatever rigid body is being controlled. And we then also turn off gravity. So I'm just going to go to overrides and do apply all, make sure that's properly applied to it. So at this point, I should be able to run it, and largely nothing should be different. It should just actually still work exactly as it could before. I can jump, everything like if that behaves as it did. And that's what we would expect to have happen, because the gravity track is feeding through the acceleration due to gravity. The gravity manager is keeping track of everything. So all of that is working as we would expect it to. Now, that's the player motor scene. We've also got the AI motor. So I'm going to do a similar update to this, and I'm going to give it a gravity manager as well. And we'll do the same setup where we give it some global gravity. Not that it matters for the position for the gravity manager, but I will reset that back to 0. And then on the AI itself, we're again going to add in a gravity tracker, link it to the rigid body and turn off gravity. And we'll update our prefab. Now, an important thing with this, we're adding this in because the character motor now expects a gravity tracker. And the AI is going to be able to use that because the changes we'll make will be in the base character motor. However, there is a very important limitation with Unity's nav mesh. That is that Unity's nav mesh system assumes that the ground, so whatever essentially vector 3 down is pointing at, that is the surface where nav mesh will be built on. It can't build nav mesh that is on, the upper part of a ceiling or on the walls. So while the character is theoretically capable of being able to move in regardless of the gravity, the nav mesh agent is not going to be able to generate actual correct data for anything other than gravity that is pointing directly down. We'd need to do other work there, and not insignificant work, to make that behave. So all we can do really with the AI version of this is just make sure that it still works, the character still moves around, which we can see they do. So they're able to move exactly as they could before. So that's just something to be aware of. And just because the character motor is going to support, gravity where the ceiling is actually our floor, nav mesh won't without further changes. And not insignificant changes. They're quite major ones that you need to do. So, okay, let's go back to the player motor, because this is the one where we want to actually focus most of our work on. So what I'm going to do is I'm going to create another version of this scene. So we're going to end up with a bunch of different versions of the scene that allow us to easily just sort of test the behavior of it. And so we'll end up with ones that where, like it currently is, where we have a regular, positioning of where gravity is coming from. Then we'll set up an inverted one. We'll set up ones where we have a spherical world. So we'll get all those different ones set up so we can just very rapidly and easily test that the configurations are working. So first thing I'm going to do is create a duplicate version of this. And then what I'm going to do is I want to be able to take this scene and invert it. So first thing I'm going to do is I'm going to grab all these little bits like our damage zone and our surface. I'm going to put them under level geometry because that'll make it easy for me to update this. And then we also, our HUD, all of that is fine. So those bits are all good. But what we can then do is we can take this setup and I'm just going to rotate it. So it is now upside down. So now this, we can see our orientation here, Y still points up, so this is now inverted. Then I take the player and I'm going to invert them, and I need to adjust their position, potentially. No, actually their position looks all good. But what I do need to do is I do need to change this so that gravity is now coming from the other direction. So we change this, so now gravity is pointing up towards the ceiling. So that should mean we have gravity holding the player against the ceiling, but as we'll see, it's not going to be quite enough. So let's test this. It's not going to work, but it will not be unamusing. So we can run and we immediately fall. So there's things we obviously need to update there in the character motor. And now we are at the position where we can go and do that. So we've got the player character motor here, but we'll actually go to the base character motor script. That's going to be where the majority of changes are that we need. So first things, we need to actually make it that we want to have it require component, and it now requires a gravity tracker. We're going to have down here where we record the gravity tracker, which we'll call local gravity. So we've got our local gravity. We then need to retrieve that in a wake. So local gravity, and we can get component of a gravity tracker. Now what we want to do is we want to start going through and looking for things that need to be updated. And in particular, we're looking for things we might be referring to stuff like vector 3 up or vector 3 down, or the Y components of vectors. Those are all things that we want to be keeping a particular eye out for. Now we do encounter very early on one where that's happening with the collider, but this is a case where we're adjusting the collider's center, and that happens in local coordinates. So anything that we're changing that's purely, entirely in local coordinates is actually fine. We don't need to change that. So we keep going through. Now, not seeing anything just yet. All of these are not referring to any vectors at this stage, but then we hit our is grounded. So this is one of the first ones that we do need to make a change to. Because the way the grounded check works is it looks from a point a little bit high, a little bit higher than our feet, down. But we were using the world sense of up. So we have to change that to local gravity up. And when we do the raycast, we want to do that as local gravity down. So that will update that. That should mean it's properly checking. So far, the rest of the changes there looks okay. Then we get to the updating of movement. So it's using transform forward, which is fine. That's always going to be relative for the player. But we do have these ones here then when it's going and trying to move up a slope. So the movement vector, we're seeing it projected on the plane. It's checking if it's trying to move up too steep a slope. So that's actually one where we would need to update that. So that would go to local gravity up. So it'll check if the angle is greater than our actual up direction. So that should work well. Similar here, our movement vector, and this was the thing that was causing us to fall. Our sense of down is actually local gravity dot down. Now the rest of the logic here looks okay. We're just using the velocity, health and stamina areas are going to be completely fine. And then we get to the checking for the step up, which we can see with the checking for the step up. We do have things where we're using stuff like vector 3 up and vector 3 down quite a bit. Like it's doing, again, raycasts. So anywhere where we're doing ones like this goes to local gravity up. We also want to check, so again, local gravity dot up. The raycast looks okay. The rest of the bits there are looking all right. So we're using our up vectors. Now here, where we're doing a raycast down, that should be local gravity dot down. Here, where we're doing, again, checking steepness. Steepness is the one that's probably most likely to break. It's very, very likely to break because of it's doing that check for the angle. So that is one that we might find we do need to do some further updates to. Now, jumping is going to be another one because, again, our positions where we're checking for things like the ceiling has to be based upon local gravity up. Sphere cast, also local gravity up. Now this, our movement vector, we're applying it like this, and that's not going to work because it might be that up, might be on the x-axis, might be on the z, might be on a mix of ones. So the intent of this line is what we want to think about first. The intent is to override the current gravity and set it to purely the jump velocity. So it's to take away any current velocity that is due to other things and override it with the jump velocity. So if we want to get the current movement along the gravity vector, we can do that. What we would do is we would do a vector 3 dot dot of the movement vector with local gravity, and we could do this with local gravity dot down. So that's going to give us the component of our movement vector that would be trying to move us down. And then if we take our jump velocity and we're going to add to that, so it's going to be able to counter the jump velocity. And then what we would do is, rather than being movement vector dot y, we do a plus, and we would say local gravity dot up multiplied by this. That's going to make it so that it's trying to move it along the direction of the gravity. So that should give us jumping feeling the same regardless of where we're oriented. So that looks like that should probably do it. Things for updating stuff like the camera, those are fine. Those don't need anything specific because they're always in local coordinates. We want to check the player as well. Player stuff looks okay. Again, Those are all local coordinate systems, so being local coordinate systems, we don't need to actually do any changes. So the camera offsets, things like that, those all look okay. So conceivably, we go and run this, it should actually have the right setup. Now, it has gone and added in another gravity tracker. We will update the prefab in this case. So that can happen if you do a require component on something that has a prefab. So it's probably done that for the AI one as well. But let's test this. What we want to hopefully see is that we can, firstly, we don't fall, and that we can move around successfully. So I can move, and that looks okay. Jumping works the same as it did. Can I move up a slope? Slopes are the bit that I figure is most likely to break. And I can. And it's weird because I am inverted at the moment. And it seems, I want to just prove that I am inverted. So we can see Y is pointing up and the player is here and is successfully moving on something that is entirely upside down. So this is great. That's working. Let's test stairs because, slope's working. Good. Let's make sure stairs work as well. Again, if there was going to be something that was going to break, things like slopes and stairs, and they still actually work. I can still move up and down stairs. I can fall. Everything still actually works, which is fantastic. I can't go up super steep slopes. Do my acceleration and slow down strips. Those all work. Crouching still works. So I can handle the gravity being from any location now. And I can still fall, except by falling, I'm actually moving towards the sky. So, okay. That's one of the test scenes that we've got. Let's, that worked pretty well. I'm pretty happy with that. We did actually modify the wrong scene though. So if we take a look at level geometry, I modified my base scene, not the gravity test one. So I will actually do a little bit of renaming of these. Test scene, normal gravity. And we'll call this one inverted gravity. And I'm going to do one further one just to really mess with it. And what this will be is I will call this sideways gravity. So for normal, everything is positioned like that. That looks good. Level geometry is as it should be. We have an inverted one. And then let's have sideways gravity, where we will take our level geometry. And what I'm going to do is just parent the player to that to make this a little bit easier. So that it's going to go back to how it was positioned. But then let's rotate it like that. Just so we can make sure the gravity works regardless of the direction that it's coming from. So now I need the gravity to be heading in the negative Z direction. So this should be minus 9.81. So let's test this out. Make sure jumping, things like that are still working. Again, that's the ones that I really particular want to check because those are the bits that are most likely to break is jumping, stairs, and slopes. If anything's going to break when you mess with gravity, those are what will break. And it works. And I am, if I bring this so the game view is here, so we can see this mayhem and the scene view here, I am moving and I am not aligned to the world sense of up. So we can handle the different gravity. This would also work if we used a spherical gravity source. It would be able to be having us move along that very happily, and the gravity just adjusting and aligning. So we can just do and I'll use the normal gravity as the base one in this case. So we'll do spherical gravity. And with this, first thing I need is a sphere. So what I'm going to do is I'm going to use ProBuilder for setting this up so I can have quite a large sphere. So we want it to be a sphere, we want it to be center, do like that. And I'm just going to make it that the size of this is, we'll go for 500 in all of the axes. A lot of subdivision, so it's a decent size. Position it like that. Now I will get rid of these bits of the level geometry, and I will get rid of things like those surfaces. Damage zone can stay, but this will be a small moon. It's going to get a gravity source, not global in this case, but a spherical one. On the gravity manager, I will get rid of the global. And what I will say is this, I'll just use the constant gravity of 9.81. So it should mean the player is always being pulled towards the center of this. So let's run this. And what I should be able to do as the player, and you can see here, I can run around. Regardless of where I am on this, I can jump, and I'm always jumping the same amount, and I'm always stuck to the surface of the planet, even when, as we'll find if we check in the scene view, the player is now way over here. Now, this could be something where, like, you could also start tilting the capsule for the player. Like, that's something where we aren't currently doing that. We are, for the player, their rotation is, if we look, their rotation is always sort of staying the same. So we want to really actually rotate it so as the player moves, their actual capsule is changing so that they're actually aligning to the gravity vector. So we'll make that change as well. So to solve the thing of aligning to the current gravity, because we need those capsules aligning to it, this is something that we want to solve in the character motor itself. And in terms of how we want to solve that, so the key thing is we need the capsule to align to the local gravity up. Now the challenge that we've got is that we're able to be yawing the character, things like of that. So that means that we need to make sure that when we're applying this, that we take into account the current yaw. So it's very easy to get it that it is heading in completely the wrong directions, things like of that. And in terms of the player motor camera, the way it works is it's taking the local rotation, it's applying Euler rotation here. This we will probably need to change. That's something we'll take a look at. Likely we might find we need to change that. But we definitely, for doing the alignment, so AIs should get this alignment as well. So this is something that's good to do in fixed update before we update any of the movement, things like of that. So what we can do is we can take and get a quaternion. So when we're working with rotation, in particular complex rotations, quaternions are going to be much safer and more reliable. But we can get the angle between, well, what is our current sense of up and what is our required sense of up. And then, okay, that's good. We can, if we take that and we merge that with our current rotation, which the way we do that, So if we are factoring in, we're adding in our current rotation with quaternions, multiply is an add. That actually is going to give us a new rotation. So align to the local gravity vector. So with that alignment in, what we're hoping to see is that the character can move around and that they will very happily be able to, when I get to the far side of the sphere, and if we watch the transform rotations there, you'll see there's a progressively increasing X rotation, as there should be, because I'm heading to the far side of it. So once I get to around 90, that'll probably be a good spot to test it, because by then we should be rotated fairly heavily. So first thing I want to check, okay, yaw works nicely. I can jump, and then if I take a look in the scene view where the player is, they are nicely aligned to the surface, which is what we wanted. And if I go even further, so I'm going to head to the other side of it, and again, I should be able to be jumping and looking around. So all of that is working still. So I can jump, everything is behaving the way that I need it to. So we've got everything aligning properly. We want to go back and just double check our other scenes. So normal gravity, make sure that scene works correctly. Very easy for us to have potentially broken things with the range of changes. We'll just double check. So this still works okay. Can still use everything. Let's check sideways gravity. And then we'll also check inverted. So sideways, still working fine. I can move upstairs. And then let's check inverted gravity and make sure that works okay as well. And as a final thing, we will also then check that we haven't broken the AI scene. So far, everything is good. Finally check the AI one, make sure that it is still working correctly, because that's something where we want to make sure we haven't broken anything in the process, and it still works. So we now have our character motor able to support variable gravity coming from different directions. You could have multiple sources of gravity, so player getting affected by other planets, things like that is now a very doable thing. So dive on in and experiment with this. I've got only very simple gravity sources in there, but you could start to do much more complicated ones where the gravity is actually based upon what surface the player's recently been in contact with, things like that. So there's a lot of really cool, nifty things you could do with that. So dive on in and experiment, see the kinds of things you can be doing with that. Thanks folks, hope you found the video interesting and helpful. If you have, chuck in a like and subscribe. If you've got any questions, chuck in a comment below. If you're looking for the code for the project, the code is available up on GitHub, and there is a link to that in the description. There's also a link to the video archive, where you can search and find this video and other ones, and you can look based on keywords, things like that. And if you're looking for other ways to support the channel, then I do have a Patreon, and there's a link to that in the description below. But until next time, bye.